Well, I say, welcome. I'm George. This is Barley and Hops, and we're still in the beginner's guide. Yes. Just finished publishing number 8. This is number 9. And we're going into another type of a mash. 2-row barley. Yes, you better believe it.
Made out of buckeye, pottage, and corn, and was bottled up in some barn.
Yep, here we are. And we're so glad you're here. Please subscribe, share us with your friends, comment below. All those things that we always cover because we need to. Oh, my goal is to at least hit, maybe 100 million. We're at about 50,000 subscribers. We just need to keep reaching for the stars. All because of you. Thank you. Now, today we're going to do a mash, and we're going to do straight grain. We're going to use 2-row barley. I want to explain a few things. Take this opportunity because this one's going to be pretty quick. First of all, the one that we did, this is number 9. The one we did, number 8, on the corn mash, I'm already starting to get questions. And, the questions always revolve around, can I do? A lot of times it's should you, but let's settle this. Can you use cracked corn? Yes. Can you use whole corn? Yes. But you do need to grind those up so that you can get at them, because you know that if you just throw corn in a batch of water and you throw yeast in there, nothing's going to happen. Okay? Just understand, if your stomach acid cannot eat through a kernel of corn, you know what I mean? Because you see that the next day after a good helping the day before. If your stomach acid can't eat through it, what makes you think that a yeast cell is going to do that? Just keep that in mind. So, yeah, you can use all those things, of course. Yeah, you can change the amounts. But remember, the key is water. Make sure you have enough water in order to suspend all of that stuff. Okay? So, we're going to get right at it. And that's why, now this is another option. Remember I told you yesterday, that was yesterday's video, that there's 1,000 ways to do what we do. I just show you one at a time, and all of them work. And all of you have your own techniques. But technique is important if it's effective, but don't violate the process. See, the process is all the same. It's just the technique, how you go about it. Whether you use a 2-gallon bucket or a 3-gallon bucket, that's a technique. But the process is the same. And that's what we're going to do today. Now, we're going to use 2-row barley. Straight up 2-row barley. I've got 4 pounds here, and I've got a little over 3 gallons of water, 12 liters. Okay? And the reason I'm going to do it this way is because I need actually 8 pounds of this to get to where I want to go. This is a really good base for a bourbon. I can mix it with another mash, maybe some of that corn mash. There's a lot of things you could do with it. But I want to make sure I have enough water, so I got to run this thing twice because it's only so big. See, one of the big mistakes that people make is this only holds 20 liters at the most. And they'll put 10 or 15 pounds of grain in here, and then all of a sudden it swells up, and you can't get at anything. Nothing can happen. And then you've got this total mess that you've got to try to recover from. Oh gosh, yes. And then when I recommend that you dilute it, you start pulling your hair out. Why? Use enough water in the first place to make your process that much easier for you. So right now I'm going to use, a pound, maybe 1 1/4 pounds per gallon. Okay, now remember when I did with the corn, it was about 1 1/4, 1.5 pounds per gallon. I had 4 gallons and 5 pounds, so 1.2. Same thing, 4 pounds, a little over 3 gallons. And there's a couple of different steps. Now, you do not have to, please, listen, you do not have to do what I'm about to do with a flaked product. Flaked product. Flake corn, flake rye, flake oats, your cereal grains, okay? Those are totally starch, okay? Now, these are grains. A malted barley, a malted rye, there's so many. There's a malted corn. And that means that it's been brought to it's been hydrolyzed, brought to a germination temperature, allowed to start to sprout, and then the germination process has been halted. Sprouts knocked off, and it's set aside. It is now a malted grain. That's what a malted grain is. Now, so in that malted grain are loads and loads of starch, already formulated sugars, and what's left over is amylase enzyme. Now there are some beta amylase in there as well. And we discussed this once before. The substitute for beta amylase is glucoamylase, because you can't extract beta, unfortunately. But so they make a product called glucoamylase, but that works at fermentation temperature. Kind of does about the same thing. But the beta amylase that's resident along with the alpha amylase works on its own at the proper temperatures. So now there's a lot of different things. In the brewing community, we know there's a decoction method. You can go through a protein rest, a saccharification rest, and all that stuff. We're going to make this real simple. I got 2 points that I want to make sure that I achieve. One is I want to do the protein rest, which is, 130 degrees Fahrenheit. Now, that's 55 degrees Celsius, and I'm going to put these up on the screen so you got them. And the reason I'm doing that is because, and I'm going to use Celsius in this particular video because that's what this is marked in. It's just that much easier for me. And I'm going to hold it there for 20 minutes. Now, what that protein rest does is it allows that grain to, again, soak up, release those starches, start to activate that beta amylase. And then I'll bring it up to 155 degrees or 68.3 degrees Celsius. And we're going to hold it at 68.3 degrees Celsius, or better known as 155 degrees Fahrenheit. We're going to hold it there. Most of your conversion will take place in the first 30 minutes, but we hold it there for 90. Just to allow it to sit. And so it's only soaking at 155 degrees. That's all it's doing. And then we're going to call it done. No, we're going to adjust. We're going to make sure the pH is correct. Then we're going to cool it down. Remember, we did the same thing with the corn. And then we're going to place it into a fermenter. And then we're going to wait, because I had to do another one of those. And then we're going to add them together. But remember, we've got to go through the sparging routine as well. And I've got another demonstration of another way to sparge these grains as opposed to the way we did the corn. Again, technique versus process. Process is the same. Technique may be a little bit different. You ready? Let's hit it. Now, you ask yourself, why do I make such a big distinction between technique and process? Because process is most important, and technique is just something you develop. Now, everybody in our community doesn't have a digiboil. Everybody in our community does not own one of these, and this is just an electric kettle, for lack of better words. It could be used as a coffee urn. It's very useful, okay? Everybody doesn't have all the same equipment, so there are different techniques for getting at the same thing. And so that's why I bring that up. Now, what I've done here, now remember the one when we did the corn mash, we had a colander inside that large 30-quart pot, and we used a bag, a sparging bag is what that was, a rinsing bag, inside so that we could keep the flake corn separate, and so we could remove it a whole lot easier. What we're going to do with this one today, because the way these are made, of course, the heating elements are at the bottom, and there's also a sensor down here at the bottom that protrudes inside, and when that gets gummed up, it just shuts itself off. It shuts itself off because it overheats. And your grains, if they lay on the bottom and that heater element comes on to keep it warm or to heat it up, because we're going to heat it up, it starts to burn and scorch those grains. And you've had probably that experience before, no matter what you're using. I always recommend that you have some sort of a standoff on the bottom. My solution for that is just a simple old screen colander. Now this screen colander has looks like about a 1/2 inch standoff on the bottom, but it's also curved so that my sensor sits out here and it won't get gummed up, and my grains will not rest on the bottom. Now, what I've done is I've just cut the top of it off because it was one of those that had a lid, and it fit perfectly on top, but it wouldn't go inside. Once I cut that rim off, it fits. It just drops all the way down to the bottom, and oh, by the way, it's perfectly the same size as the interior circumference of this, so that no grains kind of fall over and get down at the bottom and scorch. All right, we are at 55 degrees centigrade, Celsius, centigrade. All I'm going to do is, check the pH. I do that every time just to blow anything off that may be there. Up, 6.1. What do we say? 5.2 is our goal. So let me get a little bit of citric acid, and or I could use lemon juice. I could just squeeze lemon juice in it, but I happen to have citric acid. Now, after you do this a few times, you kind of know how much it's going to take, which isn't really a lot. Just add it to you. And then what do? Test your pH. Oh, these meters are just amazing. Ooh, 5.6, 5.5. There she goes. She settled out at 5.5. Well, that's close enough right now for this kind of work. So at that level, nope, we're going to throw just a little bit more. Just what the heck. Because I'm pretty certain my grain's going to bring it back up if I don't watch it. Put about the same amount in, give it another swirl. Ooh, yeah, well, that little bit brought it down to 4.4. Okay, well, I anticipate now that my grain will bring it back up a little bit, but it's not out of the realm of usefulness. You see, I need that acidic environment for a lot of different things. And one of them is that to assist all of those free amino nitrogens that will be produced, and a lot of those other things that are going to happen that I just can't describe. So we're going to add our 4 pounds of 2-row barley that has been crushed. This has been milled. See, and all we do is just pour it in. That's a lot of grain. But you'll notice that I've got a lot of room in here. You know, I got another 4-pound bag I could throw in there, but I don't want to do that. Because I want to do it. I want to make sure that I take advantage of the proper process. And that is this. So, we shall leave that, for the next 20 minutes. And there's no way to check it after that to find out if it's been long enough, so might as well leave it for 20 to 30 minutes. Just leave it sit there. And then we're going to crank up the temperature. We're going to bring it up to, what was that? Wait on you. Yeah, 155 or 68.3 degrees Celsius. And that's the point. That's called the saccharification rest. And that's where amylase converts starches into fermentable sugars. Be right with you. We have waited our required time, and I sit here before you now with a sample, and I've got a really good angle on this so you can see it a whole lot better this time. And I've got my eyedropper here I'm going to drop in a drop of iodine. Now, I want you to see what happens. That's just a drop. And you notice how quickly that dissipates. Doesn't turn black. What's that tell us? I even dropped like 3 or 4 more drops in there, and look, it's still. That tells us we've converted all of those starches to fermentable sugars. Now it's time to do the hard work. Yeah. So I'm going to transfer this. Actually, I'm just going to dump it from here into a bucket, and then I'm going to show you how we're going to strain that grain real quick. Because remember, I've got to do this again one more time. Yep, now comes the fun part. What I'll do first, see, this is one of the advantages of having one of these. And again, this is only technique. So I'm going to remove all the liquid out of here, and that way I'll have all the grains left. And then what I intend to do, I got to grab this. What I intend to do is that since I'll have that full of the wort at this point, I've got a strainer, and I've had this for years. Great big funnel, a BAF, big ass funnel. And what I'm going to do is place this over top of another bucket, and I'll put the grains in here, and I'm going to sparge through. What did we say sparge was? Yeah, it's rinsing. We're going to rinse all the grains. And so what I should have left is probably, I don't know, somewhere near about a little less than 3 gallons. And so that means I got to go through this again to get the rest of it so that I can fill up a fermenter and we can start fermenting. You know, one of the things I love about this hobby is that you learn new stuff all the time. Believe it or not, that mesh screen that I put in there with the standoff was so efficient that I just sparged while it was in here. I just poured my sparge, my rinsing water in here, and let it run out. So I didn't have to use this. That's pretty ingenious, and it's something I have learned. So there it is. It's just about done. And we're going to go on to our next step, which is to refill this. Now, let me show you something. Oh, what did I do with it? Oh, here it is. It was in the pot. This is what I have left over. You see that? That's just like, that's the leftover grains. Now, what are those good for? Oh, you know, believe it or not, there's a really good dog biscuit recipe that I need to dig up, because you mix those with a little bit of egg, flour, and peanut butter, and you bake those. They make great dog biscuits. But the other thing that it's good for, and remember, we know we're not going to get 100% of the sugars out of that. Again, what's that environment? It's ripe for growth. So if I want to use some 2-row barley and start a sour mash, I've got the perfect bed for that sour mash to get started, along with the flake corn that I have set aside. So we're going to do that, and I get the next batch going. And when I get done with that next batch, I'm not going to go through this whole thing with you. We'll just add it, and then I'm going to put it in my fermenter. We're going to start fermenting.